Hello again, AP Chemistry students, and welcome to your Unit 5, Lesson 3 of your summer homework, which is all about solutions. So let's first talk about vapor pressure. When a partially filled container of a liquid is sealed, some of the particles will vaporize while some will condense. The gas particles exert a pressure on its own liquid, and that's called vapor pressure. If the temperature increases, more gas will evolve, and then the vapor pressure will also increase. So the boiling point at which the temperature and the vapor pressure is equal is called the boiling point of the liquid. And that's when the liquid is going to become a gas. So the normal boiling point is the temperature at which a substance boils at 1 atmosphere. So at higher altitudes, such as Denver, Colorado, the air pressure is much lower due to decreases in the amount of air molecules. So therefore, the water will boil at a lower temperature, and so food will take longer to cook if you're at a higher altitude. At low altitudes, the opposite is true. So let's talk about some properties of liquids. You have surface tension, and that's the elastic force on the liquid surface. The stronger the intermolecular force, the higher the surface tension. Let's talk about viscosity. Viscosity is the measure of a liquid's resistance to flow. The greater the intermolecular forces of attraction, the greater the viscosity is going to be, and the slower it will flow. So maple syrup as opposed to water. Maple syrup has higher intermolecular forces, so it has a greater viscosity. If you increase the temperature, then the viscosity is going to decrease. Solutions are homogeneous physical mixtures of two or more pure substances. They should be transparent and pass through a filter. In a solution, you're going to have two things. You're going to have the solute, and that is dispersed uniformly through your solvent. The solute is going to be the minor part. That's what gets dissolved. The solvent is going to be the major part. That's what does dissolving. And water, for our purposes, is going to be the universal solvent. So aqueous solutions have water as a solvent. The solute can change phase in order to dissolve. And solids and gases can be solutions too, like air and alloys. Alloys are going to be a solution of two different metals that come together. So when you're talking about solubility, if it's in a solvent, it is considered soluble. If a solute does not dissolve in a solvent, it is not soluble and forms a solid at the bottom of your test or precipitate. Solubility refers to the amount of solute that can dissolve in 100 grams of water. So there are going to be things that are going to affect the solubility of a substance. First, it's going to be the chemical nature. And so you're going to remember the rule like dissolves like. So polar solutes dissolve in polar solvents only. Temperature is your second one. If you increase the temperature, you're going to increase the rate of solubility. For gases, the relationship is reversed. If you increase the temperature of a gas, the solubility of the gas will decrease, because if you increase the temperature of that gas is going to want to get out of that solution faster. So let's talk about pressure. This is for gases only. If the pressure is increased, the solubility increases. So when you think about how we manufacture and we bottle up pop cans and pop beverages, they package these pops and soda pressures. So when you open up a pop for the first time, you hear that gush of gas coming out of it. That is the reason why you're hearing that, because that gas is being heated, it wants to release, and that's why it makes that sound when you open them up. So let's talk about types of solutions. We have a saturated solution, and that's when the solvent holds as much solute as possible at that temperature. In Table G in your reference packet, the saturated solutions fall on that line. Dissolved solute is in equilibrium with the solid solute particles, so some may dissolve and some may precipitate out at the same time. Let's talk about unsaturated solutions. That's when your solvent holds less than the maximum amount of solute for that temperature is dissolved in the solvent. So in Table G, if you're looking for an unsaturated solutions, they're going to fall underneath the line. A supersaturated solution is when your solvent holds more solute than is normally possible at that temperature. So when you're looking at Table G again, Supersaturated solutions fall above the line. These solutions are unstable. Crystallization can usually be stimulated by adding just a single seed crystal or scratching the side of the flask. So let's talk about temperature. Generally, the solubility of solid solutes in liquid solvents increases with increasing temperature. So if you look at this picture on the right, the higher the temperature, the more grams of solute you can get in 100 grams of water. The opposite is true for gases. So if we look at these four gases, so for carbonated soft drinks are more bubbly if stored in the refrigerator. Warm lakes have less O2 dissolved in them than cool lakes. So if you look at this, when the temperature of the solution is cold, gases are able to stay in. Once that temperature increases, the solubility, the amount of millimolar of gases you can get into that solution is going to decrease. The solubility of liquids and solids does not change a lot with pressure. The solubility of gases, however, is directly proportional to its pressure. So if you increase the pressure on the gas, you're going to increase the solubility. If you push on the gas above a liquid, you're going to push more of those gas molecules into that solution.